Hi students, this is Alex here. In this video we are going to solve the given partial differential equation. This is having the terms x and p as a product, y and q as a product, and we have a power for x. So we have to group in such a way to get f of x power m into p, y power n into q, and z equal to 0. So we need p term, and with that we have a x as a product with some power. So for that I have to take this as x square p whole square. Then only we get a p term with that x as a product with some power. In the same way we have minus y into q separately, so that we have a q, with that we have a product y with power 1, and we also have z, which is equal to z square. Now finally we got this form, and here we find m, which is the power of x, 2, and n, which is the power of y, which is 1. When m is not equal to 1, we go for the substitution capital X is x power 1 minus m. When it is equal to 1, we go for log substitution. So this is standard substitution we use. Now we find dou capital X by dou small x, which is 1 minus m into x power 1 minus m minus 1 will be minus m. The same way dou capital Y by dou y will be 1 by y. Here we take capital P, which is dou z by dou capital X. Capital Q is dou z by dou capital Y. And now this small p, which is dou z by dou small x, can be rewritten as dou z by dou capital X into dou capital X by dou small x. So from this, small p will become dou z by dou x, we have capital P, dou x by dou x we have into 1 minus m x power minus m. Now taking this to the other side, small p by x power minus m is capital P into 1 minus m. Taking to the numerator, we get x power minus m becomes x power m into small p equal to capital P into 1 minus m. And here the value of m is 2. So x square small p becomes, when I put 2 here, 1 minus 2 is minus 1. So minus capital P. So we got the x square p as minus capital P. In the same way, let's take small q, which is dou z by dou y, which can be rewritten as dou z by dou capital Y into dou capital Y by dou y, and this is capital Q, and dou capital Y by dou small y is 1 by y. So here it will be 1 by y. By cross multiplication, yq equal to capital Q. So we got even this. These two we are going to substitute in our equation 1. Equation 1 is the rearranged one. So we have x square p whole square, but x square p is minus p. So minus capital P whole square. And the second term is minus yq into z. But yq is capital Q into z. And on the other side we have z square, which is equal to z square. Now capital P minus capital P whole square is P square minus QZ, and minus Z square equal to 0. So we got the form of f of capital P, capital Q, and Z equal to 0. For this form, we take capital U, which is x plus a capital Y. Now dou capital U by dou capital X is 1, and dou capital U by dou capital Y is a. Using this, we take the capital P, which is dou z by dou capital X, is rewritten as dou z by dou U into dou U by dou capital X. So here we have dou u by dou x as 1. By substituting that as 1, we get capital P as dou z by dou u. Let's keep this P separately. In the same way, we have to get capital Q. Capital Q is dou z by dou capital Y, which is dou z by dou u into dou u by dou y. Dou u by dou y is small a. From this, capital Q is dou z by dou u into a. So we got these two, and these two should be substituted in our equation 2. Let's keep this as equation 2. P square minus QZ. P square is dou z by dou u whole square minus QZ z. So here we substituted qz and minus z square equal to 0. Now this is a quadratic expression in terms of dou u by dou z by dou u. On rearranging, we get dou z by dou u whole square minus a z into dou z by dou u minus z square equal to 0. Now the general form of the quadratic is ax square plus bx plus c equal to 0. It means x is minus b plus or minus root of b square minus 4ac whole division 2a. So we have an equation in place of x, we have dou z by dou u, which is minus b. It means a z, which is the coefficient here, plus or minus root of b square is a square z square minus 4, a is 1 and this is minus z square whole division 2a, a is 1. So on rearranging, we get dou z by dou u az plus or minus root of z square can be taken common, so we left with a square, and by multiplying minus 4 and this minus we get plus 4, then whole division 2. Now taking the square roots individually, we get az plus or minus z into root a square plus 4 by 2. We can take on the whole z common, so dou z by dou u equal to z into a plus or minus root of a square plus 4 by 2. On variable separable, we get dou z by z equal to a plus root a square plus 4 by 2 into dou u. Now let's integrate. This is log z and these terms are constant, a plus or minus root of a square plus 4 by 2, and integration of dou u is u plus c, and let's replace capital U, which is rest of the terms after writing it as it is. We are going to replace u, which is x plus a y, then plus c, and capital X I have to take from our substitution in the starting x power 1 minus m. So we know capital X is x power 1 minus m and m is 2. When I put 2 here, x will be x power minus 1. So capital X is 1 by x and capital Y, which is log y. So these two we are going to replace, and now log z will be a plus or minus, this is plus or minus, root of a square plus 4 by 2 into 1 by x plus a log y plus c. this is our required complete solution.